Okay, what is linear algebra? Try to give you a little flavor in a few relatively short videos. First of all, we can say that along with calculus, linear algebra is the foundation of very much, most of theoretical and applied mathematics. These are the entries into the whole field of theoretical and applied mathematics. They're the two courses you need. There's also discrete mathematics, which is very foundational. Among those three, you have the fundamentals for the whole picture of the field of mathematics, or a great deal of the picture, 90%. Linear algebra is especially necessary for most computer applications. Okay, so if you want to get into computer science or computer applications, you really need linear algebra. Okay, and this applies to data analysis, codes, constructing codes, breaking codes, games. It's all linear algebra. Well, when I say it's all linear algebra, I mean especially games. There's physics involved, and there are other sciences involved in these things. But the mathematical content and the mathematical applications are largely applications of linear algebra. Okay, so what is linear algebra? Again, I've told you what it's good for. Well, linear algebra is based on a number of concepts. This isn't an exhaustive list, but it's a list I choose to use in this brief introduction. Okay, vectors. Okay, now, entering this course, you're supposed to know what vectors are. I find that vectors appear not to be covered in most pre-calculus classes. This is an egregious omission, but it happens. Okay, so not everybody's going to understand vectors, but fortunately, if you understand trigonometry, just right-angle trigonometry, right-triangle trigonometry, it's pretty easy to understand what vectors are and how to do the basic operations. Once you've got the trig, that's not a very difficult topic. Simultaneous equations, which is something that you have almost certainly encountered in Algebra 1, if not in Algebra 1, in Algebra 2, and then in pre-calculus level courses. Matrices, another topic that's supposed to be covered in, an introduction, supposed to be covered in pre-calculus, but might not have. And then transformations, for which your pre-calculus, shifting and stretching functions and so forth. If you understand that, it's the flavor of the idea of transformations is kind of similar, but in some ways less complicated, although, well, there's a lot you can do with them. And vector spaces, and I can't give you much information what vector spaces are until we talk about vectors. So, we're going to talk about these things.